Hi guys, my name is Sanilan and I'm studying at University Technical Malaysia, UTM student, and I'm doing Bachelor of Geometric Engineering and I'm currently doing second semester. In this semester, we're taking several subjects and one of the subject is engineering survey. In this subject, we assign a group project and my group project is build or design a 10 km underground tunnel for speed train from Iskandar to Klia. And I'm here today to present my project with my help of my group members Sanilan and it's me, Tan Yipin and Mohammad Izzat. First we go to introduction. And what is tunnel? Tunnel is a passage where they carry people or vehicle to across a destination that have obstruction or shorten the travelling time. Tunnels in the olden days are used for mainly mining works. In recent years of technology evolved with time tunnel construction had become more commonly transport routes in the place that alternate solution such as roads or bridges impossible to build or costing is higher since the obstruction to be accounted for in order to build the necessary routes. Tunnels are constructed all around the world as the method of construction is getting more advanced, and this allows the tunnel that be impossible to build are now done. The tunnel design is multiple disciplinary activity requirement geometric design, structural design, electrical, mechanical engineering, fire safety engineering, and communication engineering. Interaction of specialist designers in each of this area is necessary to obtain the best solution. Decisions on the location and form the tunnels must be undertaken will be advised though these specialist designers. To construct a tunnel, there are certain operations or steps which are be followed or perform various tunneling operations. Next we see objectives. The first objective is students able to understand more on the how to deliver and implementing the various of engineering project. Second, student able to determine the scope of work for engineering survey. Third, student able to learn about the basic knowledge on the construction of the underground tunnel. The fourth one is students are able to produce an engineering survey project report. And after this, my group mate will explain the scope of works.
Let's have a look at scope of works, which include project overview, project scope, project deliverables, project schedule, and project management. Our project is located in Alokajah, Melaka. It is a single board railway tunnel for new speed train with full length of 10 kilometers. It is a 9-meter height times 9-meter wide horseshoe-shaped tunnel with fully concrete line. And this is our map of our project from the Google screenshot. And this is a KTM campaign which already existing in Melaka. And the railway tunnel is our project. And this is a Google map picture too. Is our railway tunnel. Then is a project scope. Our project scope including surveying for fixing location of shaft and alignment of tunnel between the shaft, designing rear tunnel portals, clarifying setting, alignments, and breakthrough error analysis in tunneling project. Then the survey work during our construction. The tunnel centerline location, tunnel stationing, and tunnel grade are transferred from the primary control monuments and benchmark located on the surface to the tunnel and are carried forward as the tunnel is constructed. Then a construction control system is established that will ensure tunnel driving tube or sub-Vickers tube placement within the allowable tolerance. Then observation wells are installed to monitor groundwater levels adjacent to tunnels and underground structures. Then surface movements are carefully monitored over the tunnels. Special recording devices are installed to record vertical and lateral soil movement or stresses adjacent to tunnels or underground structures. Then is the project deliverables. Include engineering survey report, proposal, product quality enhancements, design documents, technical interpretation, cost estimating based on project phasing schedule, final plan of project. And this is our project schedule. Our task is given on 22nd of April 2020. Then we used about 1 month to complete the report and the project. This is our schedule. Then we have a look on the project management. The progress reports, prepare weekly progress report and documenting project progress in accordance with the basic contract. Review certified payroll documentation provided by the contractor and conduct random interviews of contractor employees. Deliverables generated during the project will include the following and will be submitted throughout the duration of the project or at specific dates commensurate with the deliverables intent, which is weekly progress reports, project diaries, inspection reports, quantity records, and other documentation prepared during the course of construction. This is the costing part. Tunneling support, which is separate into two, which is fixed cost elements and time related elements. Then the tunnel construction cost, tunnel porters cost, tunnel shaft, mechanical and electrical system in tunnels. First, tunneling support. We have fixed cost elements and time related elements. Okay. Fixed cost elements are those not influenced by time or tunnel length and include establishing a secure site compound that contains service site offices, workshops, testing laboratory, and stores. While the time-related costs include labor costs for management, supervision, and general site-based labor, hired plant, and equipment servicing the site, security, cleaning, and maintenance costs. And the tunnel construction cost. This element comprises the excavation of material from the face of the tunnel and its transport along the tunnel to the tunnel construction site, which is the cost of the material of the tunnel, the cost of the precast concrete lining and their transport and installation in the tunnel cleaning and strip out of the temporary construction equipment upon the completion of tunnel boring, and the installation inside the completed tunnel of a concrete base incorporating drainage pipes, a concrete evacuation walkway, and a concrete maintenance walkway. It's overall the material of the tunnel and the construction work, the cost for the construction work for the tunnel. Then is tunnel porters. And porter structures are typically constructed of concrete and comprise parallel concrete ground retaining walls with a concrete base. In some circumstances, the porter is also required to be propped close to ground level using either permanent individual concrete props or a roof slab. This is the example of the tunnel porters here, and it's a railway truck. Then we have a look on tunnel shafts. In country areas, the shallowest shafts are generally rectangular and are centered directly over the tunnels, while in urban areas it is very difficult to locate a vent shaft directly over both tunnels, and hence additional tunnel connections are constructed from a shaft. This feature increases the cost of a vent shaft in an urban area. There's an example too. And last is the mechanical and electrical systems in the tunnels. is the mechanical and electrical system are required in the tunnels, cross passages and ventilation shafts to light, drain, ventilate and cool the tunnels. Fire and life safety equipment is also required, comprising fire hydrants, signage and communication system. This is the output of our project. Going to see the map. So KTM road, and this is a tunnel. The road all is noted in the legend with the green area and the urban area here. This is a cross section of railway tunnel, and this axis of railway track. There's a lining, concrete lining here. It's a horseshoe shaped tunnel. The concrete lining. This is gauge of electrification. This is our new speed train here, the cross section. You can see the plan of tunnel, center line and laser line here. So tunnel, and this is where we carry out our leveling work. This laser being placed here. We shoot the laser where the intersection point. They will combine here. There will be the track of the railway. You can see the plan for tunnel alignment. There's a horizontal tunnel alignment here, above here, and there's a vertical tunnel alignment. And there's a ball tunnel will be placed here. Oh, that's all for the output.
Okay guys, the next is methodology of work. First of all is tunnel planning. Almost every tunnel is a solution to be a specific challenge or problem. In many cases, the challenge is an obstacle that a roadway or railway must be bypassed. There might be a bodies of water, mountain, or other transportation route. Even cities with the little open space available for new construction can be obstacles that engineers most tunnel need to be avoid. Sometimes tunnel offer a safer solution than other construction. So how a tunnel build depends heavily on the material through which it must pass. Tunneling through soft ground or instance requires a very different techniques than tunneling through hard rock or soft rock such as shale, chalk and sandstone. Next, I will uh, discuss about tunnel excavation method. First is cut and cover. Say cut and cover is a name indicates simply excavate, construct and backfill. There are some variation to be proceed it. For instance, to be executed from bottom up or top down. Both processes are quite slow during construction. A temporary roof over the pit is often necessary to allow surface activities to carry on unimplanted. The next is New Australian Tunneling Method. In this is NATM method. The tunnel media in front of the drill, charges placed and denoted. When using this method, it's important that the structure of the soil to the tunnel is completely understood. In non-homogeneous material or cavity-filled rock, the drill and blast technique may not be the good choice. Next is tunnel boring machine, which is known as TBM. There are three types of TBM: open face TBM, earth pressure balance machine, generally used for the boring in loose soil, and the third one is mixed shield TBM for media compressing hard material interface with loose soil. So this is the quite of ground structure deep excavation and underground works in such area need extreme care. Moreover, rather than being solid, it is filled with cavities. Exposing them during excavation would be drain the cavities. Soils in the drawn into the cavities and sinkholes appear on the surface. The nature of the soil structure lead to be choice the makeshift TBM. For the tunneling, this TBM uses slurry shield to ensure in front of the tunnel cutting phase following the mixed TBM specifications. Okay, first the type is mixed shield we use in this project, and the length of the tunneling machine is 71 meters and weight of the tunneling machine is 2,500 tons, and the installed power used is 8,200 kVA, and cut head diameter is 13,260 millimeter, and this type of TBM used for hard rock and soft. Segment outer diameter is 12,830 millimeter, and advanced speed nominal is 0 to 2.5 centimeter per minute. So we next proceed to tunneling process. Okay. Oh, sorry. We first look at TBM. Tunnel boring machine TBM is innovative machine that upgraded the quality of construction industry, especially tunnel infrastructures. TBM is a machine that a rotary cutting head mounted on the front and the operation deck that is shielded behind. The machine operates on a rail track that uses hydraulic jack that is mounted at the side to stabilize the machine. The machine pushed forward by forces that will be directed break through the rock surface that will be cause the tunnel to be drilled. So this is how the TBM works to drill to drill the tunnel. The machine is designed to handle any type of ground compact, continuous and rotate head machine. This technology is very suitable for urban tunneling. This So next we talk about new Australian tunneling method, which is NATM. This method was developed between 1957 and 1965 in Australia. These main contributors to develop this method were Claudius von Reiswis, Leopold Müller, and Franz Becher. The NATM is a method that used approach integrating the principle of the behavior of the rock masses under load and also monitor the performance of the underground construction during construction. So there are se- so there are several criteria that has been taken in consideration in this method, as a method is not a set of specific excavation and support techniques. First one is mobilization and strength of the rock mass. So second is shotcrete of protection. The third is measurements. Fourth is flexible. Fifth is closing inward. Sixth is constructional arrangement. Seven is rock mass classification determining support measures. And the last method is cut and cover method. In this project, consists of 95% of using TBM tunnel boring machine and only 5% using cut and cover method. Cut and cover method was the early stage of tunneling method that was used around the world. This method was very effective until the innovation of the TBM machine that changes the tunneling industry. The main principle of this method is excavating the ground along the route of the tunnel, construct the tunnel and bury the tunnel by backfill the root with earth and compaction of materials such as sand and quarry dust. Strong supporting beams have been placed in order to support the trench from collapsing. The construction method is relatively inexpensive and usually used for subway construction. And next, we will see the tunneling process and how the TBM drill the tunnel. There are four components involved in the proper and good alignment tunnel. First is rotary cutter head, and the cutter head is made of tungsten disc and main purpose of the cutter head is for the excavation of rock. This is the part where the hard surface of the rock is penetrated through. So next part is bulk head, the portion of the machine where the precious bentonite, the slurry shield is formed, and this is the main part where the stability of the TBM and the surrounding will be formation from collapsing due to groundwater drawn down that will be cause sinkholes. The next part is hydraulic ramps. The forward movement of the machine is controlled by hydraulic ramps. The ramps is also used to set the alignment of machine straight so that the derivation does not happen during the impact of the boring works. The last part is tunnel lining erectors. The installation of the tunnel lining is controlled here. The part of the machine allows the installation of the pre-cast concrete lining continuously after the drilling of the tunnel. And now, after this tunneling process over, or after drilling process over, there will be ring building phase starts. Ring building phase starts. A complete tunnel ring consists of several lining segments made pre-be reinforced. These are made in special factory above the ground. They must be matched exact size required and are taken into the tunnel on the flatbed rail cars. The concrete segments are fed by the concrete feeder and lifted into a place which are in using a vacuum. The hydraulic cylinders are temporarily retracted in order to provide enough space for the new segment. The segments are positioned with the millimeter precise and held in the place by cylinder before being filled bolted into the positions. The conical keystone is put into the in from the front to complete the tunnel ring. The hydraulic cylinder is extended again to secure the segment into positions. During all this work and machines During all this work, people and machines are protected by the shield skin from the saturated ground where the water is under pressure. All the readings are displayed on the monitor in the central control cabin and fed back on to the machine operator. Each section of the ring will complete the next tunneling phase starts. Next, I will present about underground tunnel surveying. Underground tunnel surveying. First, there are several procedures and methods of underground tunneling surveying. As initial procedure to carry out the preliminary survey that is later made more precise by surveying the line on the surface of the area under consideration. Besides that, from the start of the excavation as the part of tunnel construction is essential to keep up every minute accuracy with the center of the line that is already marked. When a new area excavation is commenced, the center of the line before finished work has been carried forward over the new phase. No shifting of center line vertical or horizontal direction is accepted when the opposite face meets with the adjacent headings. The procedure of the leveling is carried out in a normal way, but areas with the steep slopes are measured with the outermost scale. This is ensured by having equal values of backside and foresight. This would reduce the errors that can be caused by humans, like improper and mal readings of the instruments. These are two methods can be employed to measure the horizontal distance. There are steeping and inclined side as these methods can be employed based on the area consideration and convenience. The steel tape used for measurement and check for the errors due to any cause of tension and temperature changes. And this diagram shows the alignment of the curved line based on the which construction must be proceed. The center line of the curve in the figure is alignment through the center of the tunnel must be proceed. This is the curve must be determined. The headings consist of short tangents and drawn to the curved line AB, BC, CD, and etc. Then locate the center of the line of the area offset from the above mentioned tangents are set off. When the heading proceed up to x, y, and xy point like n on on of the calculated offset example NO that will intersect the center of the line headings. After each blasting of heading phase, the center line recommended being transferred. The transferring of center line is method that be done with a great care, precise and accuracy. The accuracy throughout the execution of the same must be guided as it can give up many related problems. Carelessness can be cause the lines from the opposite faces not to be met. Even small deviation from the centering can cause overbreaking. This whole undesirable work brings large expenditure that is has to be the problem because more tiring when the proceeding undergo the hard rock strata. Next, I will present about how to transfer centerline into the tunnel. Through the shaft constructed, the plumb bob weighing 22 lbs are taken down through the shaft, thus transferring the two centerline points to the bottom as shown. This is how they transfer the centerline to the tunnel. It is carried out vertical downwards. The plumb bob are suspended with the help of piano wires that are passing through the grooves that is connected to the shaft of the easy level movement of the plumb bob. When the plumb bob reaches the bottom, they are replaced by heavy iron so that the weight will keep the wire straight. For the high precautions of wire to resist and kind of vibration or oscillation, it can be immersed in the container of oil. Once level, the line joining of the two plumb bobs are extended with the help of theodolite and placed on the shaft floor that is designed with the respect to one point of the shaft roof. The same piano wire are and the same piano and the plumb bob combination can be used to transfer the tunnel grade to the shaft bottom. Here are 5 feet below the spring heat level of 2 points are marked on the wire. Initially, the reduction of the level, the top mark is determined with the respect of benchmark example of a point near to the mouth of the shaft, and later the reduce the level of the second mark is also determined. With all the measurements, a benchmark is determined at a point of the tunnel side wall, and lastly, based on this benchmark, the floor levels are transferred and continue the measurements.
Hello and Assalamu alaikum. I'm Muhammad Izzat bin Razli, and now I will continue about my part is survey instruments and software. Okay, let's continue. Okay, the surface survey is the part of making the tunnel. Okay, face survey is the point in each portal points in a tunnel. Traverse connecting the portal points determine the azimuth. Okay, the first thing we need to know about it is we need to determine the azimuth distance and the difference elevation of each end of the tunnel. Okay, this is the way how we produce it. Okay, surface survey, we need to gain knowledge about this to produce the tunnel. Okay, it's also advisable that survey is based the suitable local coordinate system. The coordinate system already determined and already permanently referenced by a system of the monument within an area outside each tunnel portal. Okay, next is transferring the alignment underground. Okay, for making the alignment underground, there is three way. I make it short. Okay, first plumb bob. Okay, plumb bob use 5 kilo to 10 kilogram is suspended to the wire of the heavy twine. Then it's controlled by suspended it in a spot with high viscosity oil. From the removable bracket, the bob is suspended and attached to the surface side of the shaft. So that we use to make the alignment using the plumb bob. Next is optical collimator. Optical collimator. Okay. To produce it, the important about is this is the increase the depth of the internal shaft. It allow the establish of the vertical line. Various type of the plummet are available for upward and downward. So to produce it, plummet usually used to produce it, and then uh, it interchange between the theodolite and the tripods, okay, to produce the alignment using the optical plumbing. Okay, next is laser. To produce it, laser is the easiest way to produce the alignment because the beam is very small and lookable. It's easy to look because the laser generates the light beam of high intensity and low angular divergence and can be projected over the long distance. So laser is the easy way for us to look the alignment. Next is levels internal. Okay, to produce the levels internal, there is two way. The old way and the newest way. Okay, the always older way is using the tape, chain, and constructed rods and the steel wires. Okay, on the paragraph at the left, show we how to use the tape. Okay, the tape up on the top and the leveling instrument from the upside and the downside used to determine the uh, measure of the tape. Alright, so next, the modern way, we use the EDMI. So it's the more easier way because EDM will detect the reflector. Then the reading will be taken from it and already calculated, and the difference or leveling are already produced in it, so we just need to read only. Next is the software. So the software used uh, during producing the tunnel. Okay, first software is tunneling process control, or called as TPC. Okay, TPC is a process to analysis and a software that manage the data. It's used to manage the vast amount of data associated with underground tunneling using any type of tunnel boring machine. Okay, it read the data from the process that we use from tunnel boring machine. Okay, In addition, the data produced by TBM, TPC also capture and maintains geotechnical, structural, and excavation information obtained during the excavation of a tunnel. It monitors the real-time tunnel excavations progress through the use of geovisualizations, reporting, and alerts. This is the tunneling process control software that we use, and this is the product that we can make from using it. Okay, element analysis, FEM tunnel. Okay, the use of FEM tunnel is to design and analyze the tunnel. It has a specialized tool to definition of tunnel lining, system of anchor and rock bolts, and grouting strengthens regions. Okay, the realization factor assigned to each construction stage takes the 3D effect and the excavations into account. Okay, this picture show how the 3D effect excavation this this is how we use the finite element analysis. Then the result is like this. We can look the tunnel between in the picture. All right, next is summary. Okay, thinking of underground speed trains from Iskandar, Johor to into KLIA 2 has shown a new step taken by Malaysian government to upgrade and follow the modernity for transportation system. As we know, Malaysia usually use the old train, but now we have made the renovation. We use the underground tunnel of innovation show a good impact to ecosystem for us, such as we can less use the use of petrol, uh, with the cooperate with many people. We can less the use of cars, mm, motorcycles, because people use the underground speed railways, speed train. Okay, sorry. uh, Next is we can reduce the traffic jam. As a conclusion, the development of this underground speed train as a new and modern transportation system from the underground make a large impact to our country and then give many benefits to others. Plus, it will give more attention to engineers out there to take this chance and compete to each others to make large changes in this developing country. Okay, lastly is acknowledgement. Okay, first of all, we are so grateful to this Almighty God for establishing us to complete this project report. This project report could not be done without the effort of Sainilan, Tan Yiping, and me as well, Muhammad Izzat. Okay, we wish to express our sincere gratitude to Dr. Abdul Wahid bin Rasib as our lecturers of SBEU 1043 Engineering Service in University Technology Malaysia, Johor Bahru, because he guide us and support us to make a better report and the better progress in producing the underground speed train. After that, million thanks to our direct senior for the encouragement and sharing lots of ideas for making this this project. Okay, thanks to all of our classmates because they are willing to share the information about our projects. That's all from me. Thank you.